Hello, I'm Mark Argentiano, and I'm a neurosurgeon with over 20 years of experience. In this video, I'm going to discuss brain development and the ability to make important decisions. On several occasions, most recently during a press conference in March of 2019, Speaker of the House Nancy Pelosi has advocated for changing the voting age to 16. Speaker Pelosi told reporters that lowering the voting age would increase engagement in politics among younger Americans and would help drive a higher level of voter awareness and turnout. Speaker Pelosi is not the only prominent lawmaker to advocate for a lowered voting age. Also in March, Representative Ayanna Pressley of Massachusetts proposed an amendment to the For the People Act to lower the federal voting age to 16. If lawmakers attain this goal on a national level, the United States would be the second democracy in the developed world to adopt a voting age of 16 for all purposes. Since 2007, Austria has allowed people as young as 16 to vote in national elections. Most arguments made against lowering the voting age have been on the basis of the maturity, or lack thereof, of 16 and 17-year-olds. Indeed, available brain science bolsters the argument to maintain the suffrage age status quo. In fact, some might argue, although I'm not doing so here, that the neurobiological findings suggest rescinding the 26th Amendment to the United States Constitution and returning the voting age to 21. Numerous scientific studies have sought to elucidate the mechanisms by which we restrain ourselves from impulsive action and rationally respond to critical arguments, characteristics that may pertain to making good decisions in the voting booth. Various research groups have designed experiments to administer behavioral tests to groups of teenagers and compare the results to those of adults. Unfailingly, teenagers have been found to be more impetuous than adults and be more likely to allow emotions to subjugate reason. At the same time that their behavior was being evaluated, the subject's brain activity was assessed using specialized MRIs. It was determined that different brain regions were activated during decision-making in teens compared to adults. Relatively increased activity in the striatum, a deep part of the brain that's considered a primary component of the reward system, and the insula, a part of the brain active during psychological conflicts, was seen in the teenage brain. In the adult brain, on the other hand, activity in the prefrontal cortex, the area responsible for executive function and rational decision-making, predominated. The teenagers responded in these and many other tests compared to adults because the anatomy of the teenagers' brains is not fully mature. Certain cells of the brain, also called neurons or gray matter, send their signals via axons, a part of the neuron that's like a television cable that brings a signal from one area to the other. The axons, also called white matter, can leak signal unless they're insulated by a fatty substance called myelin. The axons of the brain do not become completely myelinated until the human brain fully matures at about 25 years of age. The last part of the brain to become myelinated is the frontal lobe, which is responsible for executive functions. You probably don't need a neurosurgeon to inform you that teens are impetuous and emotional, but neurobiologic evidence bolsters the argument that lowering the voting age to 16 would be a mistake, and the recent call by several prominent lawmakers to do so is misguided. I would love to know what you think. Feel free to leave a comment below, and if you have any questions or comments, you can also message me on Twitter.